Claude Code recently released support for nested subagents, and if you're anything like me, you're probably wondering what you can actually use this for. So in this video, I'm going to break down the ways that I think about using nested subagents within Claude Code and other coding agents. We're going to have real examples and real life demos. I'll show you some practical use cases for this. I'm going to show you how to do this in both Claude Code and Codex so you can compare the two approaches. All of the resources and everything you need for the video is going to be linked in the description below, so let's get into it. If you're not sure what a subagent is, essentially when you have an agent like Claude Code, it can spawn off another agent via a tool call. So the agent tool call will just basically create another agent, which can do work with a fresh context window. When that agent has done its work, it will then report the result back to the parent agent. This is just a very token efficient or context efficient way of working. For example, if you have a parent agent implementing code, that agent can then spawn a subagent with a fresh context window to implement a code review without being biased by the original agent because it's got a completely separate context window. So subagents are generally pretty useful. This is the tweet from Boris announcing the feature. He says, just landed nested subagent support in Claude Code, starting to experiment more with agents, kicking off agents as a way to better manage context. So he's talking about using this feature for context management specifically. And he also says the depth is capped at level 5, so this means you can nest 5 levels deep. I was able to go way past this. I think I got to 30-odd subagents, so I don't know whether this is a bug in the latest version or whether this is deliberate, but I was able to go way past this depth level. You can also see it here in the changelog where it says subagents can now spawn their own subagents up to 5 levels deep. So let's take a look at how you'd actually use this in practice, and let's see if this actually works. This is a pattern I've been using myself a lot in Codex. I think it's a really great pattern for development. So within Codex, I would typically have some kind of coordinator, and then I would spin up a new thread. And then within that thread, the agents inside that thread can spawn subagents. I find that pattern to be really, really powerful because typically with a development flow, you have a multi-step workflow. You start off by maybe implementing the code, then you spawn another agent to do a code review, and then that code review agent needs to do some kind of specialized review as well. So you might have a security review and like a correctness review or a bug fix review, whatever it is. And then finally, you do another step, which would be to like run the tests, diagnose any failures, etc. So you've got the coordinator at level 1. This is managing the overall work. This is like an orchestrator for the entire flow. The only thing that the coordinator is responsible for in this pattern is spinning up other agents and making sure that the workflow is applied. At level 2, you have the workers. These are the things doing the actual work, implementing the code, reviewing the code, and writing the tests or verifying the tests are correct. And then finally, you have the sub-workers, which are just specialized agents for the workers, basically. So you can kind of think of this as a little bit like a development team where you have some kind of manager looking after a team of engineers, and then you have workers being the engineers doing the work. These are like the lead engineers in the team. And then you have these sub-workers, which are like the lead engineers delegating to other people in their team, essentially. So I'll show you a quick project that I'm working on, which is the coding agent I'm building. I've demoed this a few times. So what we're going to do is spin up Claude in this directory. And then the first thing I want to do is actually test this recursion depth. So I'm going to paste in a prompt that says, I want you to test the nested subagent depth. Spawn a subagent with this exact instruction. We basically pass in this depth level, and then we just keep spawning subagents off that parent agent. So we're just going to keep going down the chain and see how far we can get. So we want to report the maximum depth reached. I don't think I'm going to let this run too long because it will keep going. So let's see how far it gets. So you can see down here, we have the main agent, which is the coordinator. Then we have this subagent here, which is the general purpose agent. And you can see now we're spawning multiple agents off that subagent. So the subagent is spawning a subagent, which is spawning another subagent. So this just kind of keeps going, basically. You can keep nesting these things. I don't think there's any particular sane use case for going past depth, maybe 3. But it's interesting that you can do it. I don't think there's any logical use case that I can think of or any time where I'd want to go this deep. But it's just showing you that you can actually kind of keep nesting these subagents. So what I'm going to do is I'm just going to cancel this because I think it's just going to keep going. I think the main point is that the announce limit of 5 doesn't seem to apply anymore. I'm able to just keep going here. You can see here we can keep going down to like 7, 8. This just kind of keeps going, basically. So this is the project I'm working on. You can see here, it's a bunch of Go code. And then in here, we've got a Claude directory with an agent subdirectory. So what I'm going to show you now is the coordinator prompt. This is the prompt we're going to use to implement a feature. So this is a coordinating agent. The first thing it does is fetch a GitHub issue. Then it's going to implement the code change using a subagent. Then it's going to verify everything is correct. by spawning off independent subagents and spinning off parallel subagents, basically. Then we're going to basically manage the whole workflow. That's kind of it. So we're going to basically try and run this flow and see where we get to with these subagents. So what I'll do is I'll quickly grab one of the tasks off here. So let's have a look for the tasks that we can do. I think there's a really simple one here. So Unicode safe truncation. I think this is a relatively small feature. I won't talk about what this feature is. It's just for a demo. So let's take this issue and then let's go back into Claude Code. And let's kick off this task. So I want you to work on this ticket. Then I'm going to paste in the ticket number. And then what I'm going to do is paste in the coordination prompt as well. You are coordinating a issue to PR pipeline. You manage the work. You never edit code yourself. You use the subagents to manage the whole flow. This is the ticket we're going to work on. So let's see how this kind of works. So the first thing it's going to do is fetch the issue. And then it should start a subagent to go and implement the code. So what we can do is we can kind of just watch as the subagents work through this flow. So you can see here now we've got a level of nesting. So we have our main agent, we have our code coordinator, and then we have our check runner. So this is a nested subagent now, which is running a bunch of deterministic checks. You can see here we're running a bunch of like go vet, go build commands, basically just checking the code is working correctly. So the code implementer has written the code and then it spawned a subagent to just go and verify all of the checks are passing, like does the code build, is the linting correct, etc. So this is done using a nested subagent. So the test runner is all good. So that's just running the tests. Now we're just waiting for the reviewer. And now you can see that the reviewer has now spawned a subagent itself. So we have the orchestrator, we have the reviewer, which is the worker. And then we have the correctness reviewer, which is like the sub worker, basically. So the subagent of the subagent. So now we finished the review. So we've got a bunch of findings. Again, one of the principles with agentic coding, never trust agents because every time they write code, there's always something you need to fix. So we've got a bunch of warnings and nitpicks as well. So otherwise, everything is good. So needs some minor fixes, nothing critical. So now we're going to go and fix those issues. What I like about this pattern personally is the nice separation of concerns. So you have the orchestrator whose only job is to manage the lifecycle of this whole task. So basically taking an issue and then opening a pull request at the end, it's basically trying to orchestrate that entire flow. Then you have subagents, which are working on specific parts of the problem. And then they can also spawn subagents as well. So I think this pattern is actually very, very nice. And it's something I try and adopt a lot lately. So I'm running Claude Fable here. And as you can see, I'm getting close to my session limits already. So this kind of work has a lot of downsides. Even though you're going to get a higher quality result, you are going to burn more tokens. And so be cautious with any kind of parallel work or any kind of nesting like this. You're generally going to hit your session limits much, much quicker. All right, so you can see here we've actually finished our work. So this was the pipeline summary. We had this one ticket going in. We implemented the code. We verified the code. And then we had a bunch of issues. So the code review found some issues. We reran, we re-verified, and then finally we shipped the code. So we've now opened this pull request. Interesting that you can see the token usage here. So the code implementer used 21,000 tokens. You can see here that we burned quite a lot of tokens here. So 148,000 tokens across 6 runs. 2 of them resumed / nested. So this is really interesting. You can see that no code was edited by me directly. I really love this separation of concerns. And this is the pattern I've started to adopt in my own workflow. But you can kind of see here from the usage, 148,000 tokens across 6 runs. This took 21 minutes to implement this task. So it takes longer to use these sub-agent workflows and it burns more tokens. So I would say the result is probably higher quality, but you're going to burn more tokens and it's going to take longer. So everything is a trade-off when it comes to software. This is just another example of that trade-off. When you think about these agent workflows, it's really helpful to make sure that the agents are putting details into the tickets because you're basically just reviewing agent code at this point. You're not implementing anything yourself, so you're quite abstracted from the details. So what really helps and what I really like to get these agents to do is when they open a pull request, they add the findings into the ticket. So what were the review findings? What were the test results? This is just good practice in software generally, but agents are very good at doing this. And you can see here, we now have some like nitpicks. So we could even go back now because we have some nitpicks. We could potentially go back and fix these things. If we were really bothered by these, minor findings, we could actually go back to the agent and then refix these things and update the pull request if we wanted to. But yeah, this is just a really nice flow. So this is all good. As I said in the intro, you can also do this within Codex as well. So Codex by default doesn't enable nested subagent calls, but you can change this configuration parameter in the agents section. You can set max depth equals 2. By default, this is set to 1. If you set it to 2, depth 0 is the parent agent or the coordinator. Depth 1 is a subagent, and depth 2 is a subagent of the subagent. So it's a nested subagent. The thing I like about the Codex implementation is it allows you to put a guardrail. There might be a setting in Claude Code. I wasn't aware what it is, so if you do know, let me know in the comments. But what I didn't like about Claude is by default, I could go up to like 30 levels of nesting deep. I think that's ridiculous, and it's just kind of unconstrained nesting. Just doesn't make any sense. It's kind of really dangerous, and it's going to burn loads of tokens. So what I really like about Codex is you can put a guardrail here, which is just really useful. If you do want to get access to any of the resources, I will make these available, and I'll put a link in the description below. So I put together a guide where you can see these kind of patterns that might be useful to study. The coordinator, worker, sub-worker, I think this pattern is very useful. But beyond this level of nesting, like if you go down to a level 4, I don't think it makes that much sense, and it's probably just going to burn a load of tokens and get you into a right mess. If you're interested in any of these topics, I run an AI engineering community where you can get direct access to me for help and support. I also have courses on agentic coding, how to build professional software with AI coding agents, also how to build AI systems as well. So if you want to grow your career, make more money, or just kind of go deeper on any of these topics, I'll put a link in the description below for you to check out. So personally, the pattern I really like here is the orchestrator worker sub-worker pattern. I think that's genuinely useful. It's the way I think about coding with agents right now. It's my personal preference. I like the coordinator layer particularly for running these workflows. We're no longer just prompting agents anymore. We're no longer just saying write code. What we're doing is running pipelines or workflows. Software engineering is not just about writing code. It's about planning the work, writing the code, running tests, verifying everything works, running multiple checks, creating good pull requests, and then opening changes. There's a lot of steps along the way. And what I really like about the coordinator pattern is it can manage the entire life cycle and just focus on managing the workflow while you have the subagents doing the work and then the nested subagents doing kind of like specialized work. Again, the mental model I have here is like an engineering manager who's responsible for his team. The subagents are like the lead engineers that implement the code or coordinate the work. And then you have the nested subagents at level 3, like the junior engineers who are just kind of doing smaller things or focused on one particular part of the problem. That's quite a good mental model for this pattern. That's it for this video. I hope you found it valuable. If you do find the video useful, please remember to like and subscribe. I really appreciate it. I'll put all of the links, all of the prompts, all of the resources that you need in the description below for free, so you can check this out and follow along and test it out yourself. Thanks again for watching, and I'll see you in the next one.